Hi, in this video I'm going to show you one simple linear regression problem, and I'm going to solve it with the residual analysis, okay? So I'm in section 4.8, residual analysis, validating model assumptions. This is exercise applications, okay? So this is problem 47, data on advertising expenditure and revenue for the Four Seasons restaurant follow. So we have a certain amount of expenditure in thousands of dollars and the revenue in thousands of dollars. So the question is, let the independent variable be how much the hotel advertised and y be the revenue. Use the method of least square to develop a straight line approximation of the relationship between the two variables. So I copy these two variables to here, and what I can do is I can plot that. Okay, I'm sorry. I can plot just to have an idea. So I come here, oops, right? We have the revenue as the dependent variable. Remember, you can add the titles. I'm going to skip this part. I'm going to add a trend line and then click here, more options. And then I'm going to scroll down. These are the options. I go to this one that has some bars, scroll down, display equation on chart. Okay, I can also display the R-square. This is one way of looking at that, but I'm going to use the data analysis tool as a complement, or maybe the main tool. So if you have to choose between two tools, forget about this one, just if you want to plot and see, but I strongly advise you to use the data analysis tool, okay? So if you have to choose one tool, that's the tool you have to use. So our Y range, our dependent variable, is the revenue that depends on how much we advertise, okay? And then I click labels, I click new worksheet apply, I click residuals, I click standardized residuals, I click residual plots, and I click OK. Okay? So let's go back to the problem. Use the method of least square to develop a straight line approximation of the relationship between the two variables. We did this here, okay? We did a method. Test. So if the problem says develop a regression equation, you have the regression equation here, okay? But you can also use this result to come up with the regression equation. Would be revenue equal to B0, which is this coefficient here, 29.39, plus open parentheses, you can open parentheses or you don't need to, 1.54, let's call 55, multiplied by advertising expenditure. Okay, so this would be the equation. If it says what is the equation, and then that's the same thing we have here, 29.39 plus 1.5475 multiplied by x. Okay, I round up this number. Okay, so this is the regression equation. And if it says what is the coefficient of determination, the coefficient of determination is here, is the R square. Coefficient of determination is equal to 0.69, which means that 69% of the variance in revenue is because of the variance in advertising expenditure. Okay, so this is the coefficient of determination. The problem is not asking for that. I'm telling you what the problem can ask other problems, and I'm trying to cover everything that we have seen so far. Okay, so this is the regression equation. See, regression equation. This is the coefficient of determination. Then the problem says, test whether the revenue and advertising expenditure are related at 0.05 level of significance. So we have an alpha and an alpha of 0.05. So the test of significance is testing if this coefficient here has a probability value smaller than the alpha level. So the coefficient is 1.54. The t-statistic is 3.33. If we have a t-statistic, we have null hypothesis, which is b1 equal to 0. Alternative hypothesis of b1 is different than 0. Okay? And the t-statistic is equal to 3.33. Let's go 3.34, rounding up. And the p-value is equal to 0.02. Okay, it is here, the p-value. So what we're doing, we're testing if this 3.33, this t-statistic, associated with this coefficient is connected, is linked with the advertising expenditure, and they make the connection with revenue. So is this coefficient significant? That's the test of significance. So because the p-value is smaller than 0.05, we reject the null hypothesis and conclude that advertising expenditure is significantly related to revenue. So there is a significant relationship, there is a significant impact of advertising expenditure on revenue. This is what the test of significance is asking. Okay, this is what this is asking. Prepare a residual plot of the residuals versus the predicted Y. Residuals versus, okay, to obtain the values of, okay. So this is the plot of the independent variable against the residuals, and this is used to analyze the constant variance. And we can see that kind of is constant. Maybe this observation here is too much outside of our parameters. Okay, but what this is asking, prepare a residual plot of residuals versus predicted Y. Okay, so if you want to do that, we have the predicted Y here, we have the residuals here. So what we can do is we can highlight these two columns, go to insert, and then scatter. This is the plot of residuals, and then we can add the X titles here. So these are residuals, and this is predicted value. And again, we are looking to see if they're like scattered, distributed, like in here. And we see that there is one observation that is not too good because it's too far off. Okay, what conclusions can you draw from residual analysis? Should this model be used, or should we look for a better one? Maybe because of this one. But let's take a look at the standard residuals. Standard residuals, we have them here. Okay, and it seems that there is no problem. Why? Because we're looking for values between -2 and 2, and they're all between -2 and 2. But even though this one is, like, in my opinion, not good, and I think that it's like preventing this to have a constant variance, right? But regardless of what is the final answer about a good model or not good model, about how big this residual is, and because it's this first observation here, this is the process, this is the procedure, this is how you go about answering almost all problems, almost all answers in regression analysis. The only thing left is the ANOVA table that I didn't make any question, but the ANOVA table is testing if there is also a relationship between X and Y. And if you see here, the test of significance is 0.02, which is the same 0.02 of this p-value. So they are testing the same thing, but this one is testing for like a whole. If we had other independent variables, would be all independent variables together, and here we have one test for each independent variable. I'm going to talk more about that in chapter 15. But remember, in the ANOVA we have a source of variation which comes from regression, a source of variation which comes from residual, and then we have the degrees of freedom, we have the sum of squares, we get the mean squares, we divide one by the other, and then get an F statistic which has a certain p-value. Okay, so this covers almost everything, and that's it.